The luxury off-road market operates on a very specific pricing math, where you pay a steep premium for capability. But the Jetour G700 enters the market offering hypercar-level power for the price of a mid-tier family commuter. The headline specifications read like a typo. It produces 904 horsepower, features triple differential locks, can travel 1,400 kilometers, and carries a starting price between $46,000 and $58,000. This horizontal bar chart compares horsepower per dollar, and the G700 dwarfs the legacy competitors. Established benchmarks like the Land Rover Defender, Mercedes G-Class, and Toyota Land Cruiser offer a fraction of the power at double the price. This creates a difficult choice for buyers. With the exact same budget, you can either purchase a fully loaded high-tech newcomer or a base model legacy vehicle with significantly fewer features. Evaluating this vehicle requires ignoring the marketing hype to examine the engineering. We need to know if the G700 is an off-road cheat code or a highly complex liability waiting to happen on the trail. Powering the G700 is the Kunpeng CDMO PHEV architecture. A PHEV, or plug-in hybrid electric vehicle, uses both an internal combustion engine and a rechargeable battery to drive the wheels. This specific setup pairs a 2.0-liter turbocharged engine with dual electric motors and a 31.4 kilowatt-hour battery. A kilowatt-hour is a metric that measures the total energy storage capacity of the battery pack. Traditional electric vehicles struggle with range anxiety off the grid. The G700 bypasses this by utilizing a massive 100-liter fuel tank, allowing the gas engine to act as a generator and push the combined driving range to 1,400 kilometers. When the engine and dual motors deploy simultaneously, the output is immense. This full-size SUV sprints from 0 to 100 kilometers per hour in 4.6 seconds, but that speed requires a severe physical compromise. The combination of the battery pack, the dual electric motors, and the gas engine pushes the G700's curb weight to over 3 tons. Taking 3 tons onto a dirt trail creates cascading negative effects. The extreme weight accelerates tire wear against sharp rocks, and bringing that kind of mass to a halt on a loose, steep downgrade requires immense braking power. The worst-case scenario occurs if you drain the battery completely while deep on a trail. The vehicle loses its electric torque, leaving a standard 2.0-liter engine to haul 3 tons of dead weight over obstacles. The G700's powertrain does not finesse its way over terrain. It relies on sheer brute force to overcome the physical limitations and compromises introduced by its own extreme weight. Extreme high-altitude mountain passes are inherently hostile environments that actively starve traditional off-road engines. The physics of high elevation carry a strict penalty. Thin air means less oxygen enters the cylinder, resulting in a severe loss of engine power and a sharp spike in tailpipe emissions as the air-to-fuel ratio breaks down. To combat this, the G700 includes a highly unusual feature, an external oxygen generator capable of producing 3 liters of pure oxygen per minute. Looking at this technical diagram of the engine layout, we can see the flow path connecting the oxygen generator directly into the engine's intake air surge tanks. Enriching the air with pure oxygen theoretically stabilizes the combustion efficiency, even at extreme elevations. The dual electric motors complement this by providing instant low-end torque.
Unlike internal combustion engines, electric motors are completely immune to changes in air density. These engineering feats are impressive on paper, but they contrast sharply with actual consumer behavior. 95% of buyers will simply never take the vehicle to elevations high enough to justify an onboard oxygen generator. While engineering an onboard oxygen generator is a remarkable technical achievement, it introduces highly niche electrical complexity that adds unnecessary failure points for the vast majority of owners. The top-tier Intelligent Horizon Edition includes a feature usually reserved for aircraft, military-grade rear turboprops. The intended use case is emergency extraction. If the 3-ton chassis gets bogged down in deep mud, these fans spin up to generate 3,000 newtons of thrust, a newton being a standard metric unit of force, providing a literal push from the rear. However, this highlights a glaring design flaw. Highly complex, exposed moving parts have been placed directly on the rear bumper. This is one of the most vulnerable areas on any off-road vehicle. These fans will be exposed to impacts during steep departure angles, submerged in up to 970 millimeters of water during deep wading, and packed solid with debris during heavy mud extraction. Adding exposed aviation-style mechanics to the dirtiest, most heavily abused part of an off-roader represents an incredibly high-risk gamble regarding long-term repair costs and parts availability. For buyers who want the rugged aesthetic without the extreme mechanical complexity, Jetour offers a pragmatic alternative, the smaller T2. This scorecard shows the G700 dominating powertrain and tech, offering 904 horsepower, air suspension, and superior towing. But shifting to practicality, the T2's lighter footprint wins for urban driving. The G700's battery limits boot space to 540 liters. The T2 provides 752 liters. The T2 requires a clean trade. You leave the extreme off-road bragging rights and theoretical expedition tech on the table, and in return, you get superior daily drivability and practical luggage space. The Jetour G700 functions as a rolling technology showcase. It relies on software and raw mass to brute force its way over obstacles, distancing it from the mechanical heritage of traditional off-roaders. To help navigate your risk tolerance and actual driving needs, we can use this decision tree flowchart, starting with a core question. Is this vehicle your primary daily driver or an expedition toy? If you are a spec-driven tech adopter, follow the path to the G700. Your high tolerance for steep depreciation and your desire for maximum power per dollar makes this your match. If you are an urban upgrader who spends 90% of your time on pavement, the path leads to the T2. You should prioritize its lower complexity, daily drivability, and better cargo space. But if you fall into the category of the skeptical traditionalist, planning to drive hundreds of miles away from civilization, you should reject the G700's 33 sensors and extreme electrical complexity entirely. This specific buyer must stick to mechanical simplicity. When you are far out on the trail, you need the decades-long proven reliability of legacy brands. The $50,000 off-road market now represents a stark trade-off. Buyers must decide between embracing the bleeding edge of technical ability or paying a premium for the ultimate peace of mind.